networks that's called ePMP. ePMP, we call it the new standard in wireless broadband. It's a solution that we've developed. We've been working on it for the past 18 months. And what we've done is we've built a product that's very affordable and yet delivers high quality, reliable, scalable broadband access. We've incorporated our GPS sync enabled technology on a very low cost platform. And we have what we believe is something that will help unconnected and underconnected communities gain access to the internet. We call it ePMP, and the E stands for equalize, because we believe with this product we're going to level the playing field in terms of the ability for communities to have good, high quality, reliable access to broadband. We've been in the business of providing outdoor wireless solutions for over 10 years. We have a heritage in developing solutions that are resilient, scalable, have high performance, and are very easy to deploy and manage. Now, we've combined that heritage with a bit of innovation and put those capabilities on top of a mass market chipset, an 802.11n chipset. It's a Wi-Fi chipset, but this is not a Wi-Fi product. We've developed a custom, high-performing, synchronized, scalable MAC and PHY layer that enables this solution to outperform any other product in its class in a wide area outdoor environment. Here's an overview of the solution. Like I said, it's a reliable, scalable solution, and we're making it available at a breakthrough price. You can find the pricing at Convergent's website. I'll give you the URL to that at the end of the presentation. It's a 2x2 MIMO solution, and we support 20 and 40 megahertz channels. And we've incorporated some key elements of our scalable PMP solution. These are elements we think are unique in this class of product. We've got a high-performing, configurable GPS synchronized mode of operation. And with that comes a great many benefits that I'm going to go over in the upcoming slides. And once you have that good, basic, high-performance MAC layer, the ability to support effective quality of service for high-quality data, voice, and video is something that comes along with that. In addition, even though this product is low cost and affordable, we've designed it for reliability in an outdoor environment following our quality process, and I'll talk more about that later. We're also introducing at the same time a new management solution, software management solution, which is available at no charge to people that purchase the ePMP. It's downloaded from our website and provides a way to manage the ePMP solution. The capabilities that are available today are you'll be able to download new software updates to the solution, and we're going to enhance that solution over time to add more management capabilities. So this is really just the start of a new portfolio of products from Cambium Networks. What we're introducing today is just the beginning, and there will be solutions that we're going to, enhancements to it that we'll be introducing in the near future. So let's talk a little bit about the power of GPS synchronization. This has been a capability we've had in all of our point-to-multipoint solutions for quite a few years. But it's worth taking a fresh look at this as we enter a new segment of the market and a new price point on the market. First thing is, in order to understand how powerful GPS synchronization is, it's worthwhile to understand what the problems are in deploying wide area solutions that are unsynchronized. There's two major problems. The first one's called the hidden node problem. And what happens is if you use standard Wi-Fi in an outdoor environment, the way the radios access the frequencies or the media is on a contention basis. And that works very well when you're deploying Wi-Fi in a local area scenario. But if it's in a wide area scenario, you have something that's called the hidden node problem. What happens is the radios will listen before they transmit. And if they don't hear anybody transmitting, then they will begin transmitting. And if there's some obstructions between, say, subscriber modules under an access point where they can't hear each other, then what happens is they'll transmit when another subscriber module may be transmitting, and then those transmissions collide at the access point. Now, if that happens infrequently, then it's not a major problem. But if you've got a system where you're trying to get a lot of data through the system, let's say it's you're a service provider and this is your busy time of the day, then what happens is the system can get into a mode where it does nothing more than resolve those collisions, and that's what's known as collision collapse. And the other major solution is when you try to expand the solution or expand your network by adding multiple access points, and those access points are either on the same tower or they're on towers which are close enough where they can hear each other, then if they're not synchronized, you run into a situation where they will interfere with each other. So for the example, you could have one access point that's transmitting at high power, and another access point on the same tower is trying to listen to a weak signal from a faraway SM. And even though they're not on the same frequency channel, there will be interference from the high power access point, and the transmission will not get through. So the way to solve the hidden node problem is that you can implement what's known as maybe a polling protocol on top of Wi-Fi. And that'll take care of your collision collapse issue. But the way what you have to do to solve the AP to AP interference is that you have to do some very careful frequency planning. There can be no frequency reuse within a cluster on an access point or between towers that can hear each other. And in addition to that, there typically need to be large guard bands between the frequencies to make sure that there's no interference between them. And that, if you try to expand your network to any reasonable size, that can be pretty unworkable. So the real solution, though, is a high-performance GPS synchronized solution. And there's three key components to that solution. Yes, Jeff?
1 second. I would like to let everybody know before you move on. You can ask questions, everybody, while we're going along, and we'll try and either get to them now or at the very end. So feel free. You should have a little question box up on your screen, and feel free to put them in there, and we'll try to get to as many as we can by the end. Sorry, John.
Okay, no problem. So there's three components to a high-performance GPS synchronized solution. The first one is implementing a GPS synchronized time division duplex MAC layer. And what that does is that splits the time, transmission time into what's called frames. And these frames will be split further into what's called a downlink portion of the frame and an uplink portion of the frame. So during the downlink portion, all of the access points will transmit to the subscriber modules. And during the uplink portion, all the subscriber modules will transmit to the APs. And that solves both the collision collapse issue and what I would call the primary self-interference, which is access point to access point, and also subscriber module to subscriber module. It doesn't allow you to do frequency reuse, but it does allow you to have reduced guard bands between your access points or the channels that your access points use. The other two elements of the solution are you need to implement a feature that's called automatic SM transmit power control. And this is where the access point will dynamically control the transmit power of the SMs, making sure that they're not transmitting at higher power than is necessary for them to have effective communication with the AP. And then you need to have good quality antennas that have good front-to-back isolation. When you have those two things in addition to the synchronized MAC, then you reduce what's called secondary self-interference, where you have an SM on another access point interfering with or an SM interfering with another access point that it's not being served, and vice versa. And this allows for frequency reuse. And we'll spend a little bit of time in the next couple of slides explaining that further. So the first element is the GPS synchronized MAC. And with an unsynchronized MAC, you can see that the access points are transmitting and receiving asynchronous to each other at different times. And there are times when access points which are close to each other are one's transmitting and the other's receiving. What a GPS synchronized MAC does is it lines up all those transmit and receive cycles. So there's never a case where an access point is transmitting while another one on the same tower or other towers are trying to receive. Now the power control in the front to back antenna comes into play when you attempt to do frequency reuse. In this example here, we have a 4-sector cell where we are using the same channel in 2 sectors that are opposite one another. And what happens is, there can be interference on the uplink of a secondary nature, and this happens when you have 2 SMs in those sectors transmitting. The SM on the left is transmitting, and at the same time the SM on the right is transmitting. And the SM on the left, its signal is amplified by the antenna of its access point. But the signal coming from the SM on the right will reach the same access point. That signal will be attenuated by the back of the antenna. And what's important is that you need good front amplification and good back antenna attenuation. And when you have that, then you will not have those signals interfere with each other. And that difference between the amplification and the attenuation on the back is called the front-to-back ratio. And that needs to be greater than about 30 dB in order for there to be no interference and for you to have the appropriate carrier interference in order to do the higher level modulations. So you need a very high quality antenna in order to achieve that. You have a similar situation when you're transmitting on the downlink, where one access point is transmitting to its SM and the opposing access point is transmitting to its SM, but there's some energy coming off of the back of the antenna, and that energy is attenuated again by the back lobe of the antenna. So the same situation applies. You need a high front amplification for the antenna and a high back attenuation. And when you have that, and when the difference is greater than 30 dB, then you're able to do frequency reuse and still transmit at the higher modulations. So all these capabilities in the solution really go to improving what's called spectral efficiency. And spectral efficiency is a measure of how efficiently a wireless solution utilizes the RF spectrum. It's defined as the throughput that can be achieved by a solution per the spectrum utilized. And the units of measure are bits per second per hertz. So clear spectrum is a scarce resource everywhere. And so a solution that uses that resource efficiently is going to give a superior return on investment to the network operator. And so for illustration purposes, let's assume that the network operator wants to deploy a 4-sector access point site. And let's look at the different alternatives for doing that. The first alternative is if you have a solution that doesn't support synchronization, then as I mentioned before, you cannot do frequency reuse within a cell if you want to avoid self-interference. In addition to that, you need to have pretty large guard bands between the channels that you do use. If you don't have a lot of distance separation between the radios or some obstructions between them, then you're going to need twice the channel bandwidth as a guard band between the channels that are used in the sector in order to be able to modulate at the highest modulations. And so let's assume we have a solution that does 80 megabits per second in each sector. And you have 4 of those, you can get 320 megabits per second of throughput. But you're going to utilize 200 megahertz of spectrum. You'll have 4 channels of 20 megahertz each, and then you will need 3 40 megahertz guard bands in order to reduce the self-interference. So your spectral efficiency metric is 1.6 bits per second per hertz. The other alternative is there are some solutions on the market that don't completely implement GPS synchronization. Their MAC layers become less efficient due to overhead because of a poorly implemented solution. They don't implement transmit power control, and there's poor antenna front-to-back isolation. And these solutions are not completely effective. There's no frequency reuse from this solution because there aren't all three elements of the solution. What you can do is you can reduce the guard bands between the channels. So in this type of scenario, you could get by with 1 times your channel bandwidth as a guard band. But because of the inefficient MAC layer, the solution, the throughput may reduce to something on the order of 50 megabits per second. So I've got a little math error here in my chart, but you've got 4 sectors with 50 megabits per second throughput. That's 200 megabits per second over 140 megahertz of spectrum. Your 80 megahertz for your 4 channels, and then 320 megahertz guard band. And you've got something a little over 1.1 bits per second per hertz. So it's actually less spectrally efficient than having no synchronization at all. But the solution that we're introducing today, we implement all parts of the GPS sync feature, and we're able to do 2-channel frequency reuse within a cell. We will require 5 megahertz guard bands if you're using 20 megahertz channels, and we support 80 megabits per second throughput. So the spectral efficiency of the EP&P is significantly higher. We will get 320 megabits per second throughput in a sector, but we'll utilize only 45 megahertz of spectrum, 2 20 megahertz channels, and a 5 megahertz guard band. So the spectral efficiency is 7.1 bits per second per hertz. So it's 4 times the spectral efficiency of the other alternatives. So what does this mean in a practical perspective? 4 times the spectral efficiency means that you'll be able to support 4 times the number of subscribers in a given fixed amount of spectrum, which means 4 times the monthly revenue, which means much faster payback with the EP&P solution. So that's a summary of the GPS sync capability and how powerful that is. Now let's talk about the EP&P and what that solution is and what it offers. So today we're introducing a set of radios and antennas that operate in the 5 gigahertz band. We have a connectorized radio that includes a GPS timing device in it. That's our GPS synchronized radio. And we have an integrated radio that does not have a GPS device in it, but can operate in a synchronized mode when it's the slave of the synchronized radio. Now, I don't call these radios access points or SMs because each radio can perform any of the 3 functions. It could be an access point, an SM, or a point-to-point radio, so that with no licensing, just setting a configuration setting in the GUI. And then we have 2 specially designed sector antennas, for a 90-degree sector and a 120-degree sector. And both of those antennas achieve greater than 30 dB front-to-back isolation, but at a very compelling cost. There are antennas on the market today that have that kind of front-to-back specification, but they're typically much more expensive than the solutions we're offering today. So we've taken that hardware and we've added to it a high-performance GPS synchronized MAC, which we talked about, with quality of service, 3 levels of quality of service. We've got a very intuitive graphical user interface for managing the system, and this new element management system that we're introducing today. That's the solution we're introducing today. As I mentioned, each of the radios can be an access point, an SM, or a point-to-point radio. So there's a variety of configurations that you can deploy the solution in. You can have point-to-point links that are either synchronized or unsynchronized. You can have point-to-multipoint solutions, again, that are either synchronized or unsynchronized. And you can use any of the radios for any of the functions that are access point, SM, or point-to-point radio. When you buy the radios, they come complete with a power supply. In North America, they'll also come with a line cord. And the GPS synchronized radio has a small external antenna. Cambium also sells some devices called cluster management modules, which can provide power and timing to GPS synchronized radios. Those are compatible with this radio module, this GPS synchronized radio module. So they're not required. It can get its own timing through its own internal GPS receiver, but they are compatible with the cluster management modules. And the unsynchronized radio comes with its power supply cord and a mounting strap. Connectivity of the radios are shown on the next slide here. The GPS synchronized radio has two RF connections for the 2x2 MIMO. It's got a gigabit Ethernet port. That port is 802.3 or 802.3 AF compatible. And then there's also a connector for the GPS antenna. The unsynchronized radio has two fast Ethernet ports. There's a main port that gets the power and data connectivity. This is 30-volt PoE, so it's not compliant with 802.3 AF. And then there's an auxiliary port for connecting auxiliary devices. And 30-volt PoE power is available at that port as well. So if you have a device that can run on that voltage level, then you can power and connect to it just with one cable from that port. The antennas are designed specifically for this solution. The access point radio mounts to the back of the antenna. There's a protective cover for the RF connections. They're watertight, weather-tight, but the protective cover is there to keep debris from them. There's also at the top of the antenna a slot for placing the GPS antenna that connects into the radio. It could also be placed remote from the antenna as well. And then adjustable brackets for adjusting the tilt of the antenna. Here's the solution specifications. The single radios will cover all of the 5 gigahertz frequency bands. At this point, we have FCC certification only for the 5/8 band, so the radios that are sold today are locked, have the other bands locked out. That's by FCC requirement. We are in queue to have our certifications for the 5.2 and 5.8 band. We expect that later this year. Although with the recent government shutdown, the testing at the FCC has halted, so that it's difficult for us to predict when the 5.2 and the 5.4 bands will become available, but we hope that to be later this year. And when they are, we will issue a software update for the radios, which will enable those bands. We can achieve over 200 megabits per second throughput in GPS synchronized mode in a 40 megahertz channel, and we're over 100 megabits per second in a 100 megahertz channel. Transmit power is 23 dBm, and the receive sensitivities are fairly standard for 802.11 solutions. Low power consumption, 8.5 watts, and our environmental temperature ratings are minus 30 C to 55 C. The antenna gains on the solution, the integrated solution's got a 13 dBi antenna. The 90-degree sector antenna, 15 dBi, and the 120-degree antenna is 14 dBi. Here's a list of the solution capabilities. Many of them I've spoken about before. Again, radios configured as APs, SMs, and point-to-point radios, 5 gigahertz, 20 and 40 megahertz channels. We have a quality of service scheme that has 3 levels of prioritization. The radios will automatically detect VoIP packets based on their packet classification and markings. And then there's 2 other, and those will be placed at the highest priority level. Then there's 2 other priority levels, and the radios can be configured to identify packets based on their marking and put them in one of those 2 other priority levels. It's a layer 2 bridging function with NAT capability, and each of the radios supports a configurable layer 2 and layer 3 firewall capabilities. So you can have some enhanced security capabilities in the radios. We support VLAN and SNMP v2. Now the solution, even though it's very affordable and low cost, we've designed it according to our quality process. We have what we call a reliability recipe, and all of the ingredients that are in that have been used in this solution. First one is that you need to design your hardware with margin. You need to make sure that you're running or designing the solution not to overstress any of the components. You need to use high quality of components, and you need to have built-in ESD and surge protection. So this product has the same level of surge protection that we have on all of our products, and it helps to make them much more reliable in the field. You need a robust, environmentally watertight, weather-tight enclosure. The enclosures for these radios are rated IP55, which means they're weather-tight and watertight. You need to do robust design verification, and that's something we pride ourselves in. We do very thorough testing of the products before they are released to the market. We need to also test their reliability, so we put them through reliability and aging tests to make sure that identify the weaknesses in the design and correct them. And then we need to manufacture them with a high-quality manufacturing partner. So all those ingredients are in this solution, and we expect that this to have the kind of quality that people have come to expect from Cambium products. The performance of the solution is pretty remarkable given the cost point at which we're selling it at. Here's a chart which shows throughput as measured in a 20 megahertz channel at the highest modulation, and here we are using a downlink uplink ratio of 75-25. With UDP throughput, we're at about 115 megabits per second with a single subscriber device. And then as you add additional subscriber devices, there's a little bit of extra overhead that is required in the protocol. And the throughput will go down to about 90 megabits per second or so. It remains flat even as you extend the number of devices. With TCP, it's a little more challenging to get high throughputs on a wireless link there, but we've done a good job of optimizing how that protocol works. And we start at just over 100 megabits per second, and will be in the high 70s or 80 megabits per second of TCP throughput, even for a large number of devices. So again, we've spent a lot of time designing a very efficient protocol to make sure that we get high throughputs consistently in the solution. Let's talk a little bit about operations and management. Here's the elements that we're making available to manage the solution. So we have a graphical user interface for each of the radios, and this has been totally redesigned to make it a lot more intuitive and easy to set up and get the radios configured and working. We have an element management solution which we're launching as well, which initially will support software upgrades, and then will be enhanced to support other capabilities later. We have SNMP v2 MIBs that are published along with the software loads. They're on our support site. And then a set of tools to do some debugging and testing of the solution, including a spectrum analyzer. So here's what the graphical user interface looks like. Again, if you're familiar with any of our previous products, this is a departure from that. It's more hierarchically organized and more intuitive. So large buttons at the top that you click on to whether you're configuring the radio, want to monitor some statistics, do some software upgrades, run the spectrum analyzer, and that sort of thing. The element management solution, as I mentioned, also has kind of the same look and feel as the GUI. Initially, this will support software upgrades, bulk software upgrades to deployed solutions, and then we will be updating this software over time to add the monitoring of traps and statistics and doing configuration updates. And eventually, over the next 6 to 9 months or so, we will also be enhancing this solution to manage the rest of the Cambium portfolio. So that's an overview of the solution. And just, in summary, the ePMP is being introduced today. It's available from our key distribution partners right now for purchase. We've leveraged our 10+ years of experience in reliable, scalable outdoor solutions, but we're bringing it to the market at a price that's never been seen before for this level of reliability and scalability. The key is GPS synchronized operation, the key to making a solution that's scalable and reliable and makes optimum use of scarce spectrum. It's available now, and as I mentioned at the beginning of the presentation, this is just the beginning of the portfolio. We intend to turn this into a family of solutions. We're not announcing additional elements to the solution today, but you can look for enhancements over the coming months to the portfolio. So there's more information about the solution, including spec sheets, user guides, that sort of thing, at our website. And I encourage you also to visit Convergence Technologies website for pricing and availability, or to contact your Convergence account manager. So at this point, I think we can take questions.
Yeah, currently, for everybody's information, we currently do have stock on the integrated radios, the connectorized radios, and the 90-degree sector antennas. Those are all in stock and ready to order today. So either contact your preferred account manager, or you can go online and order them directly, or call or email the number that's in front of the screen right now. That's fine. So John, would you like to go through some of the questions maybe, if you've got a couple extra minutes, and
Sure.
see if there's some that you want to respond to?
Sure. There's I'm reading one now. There's one a question about where are the coffee and donuts. I think we need to add that kind of button on these webinars. So then there's another question here about Ubiquity's AirMax. There's a question about stuck beacons on the Ubiquity solution. We don't have that issue with this solution. We, one of the things that took us considerable effort to do was to figure out how to operate the Atheros chipset, which we are using in the non-standard mode here, where we could implement a synchronized solution. So we've been able to avoid some of the problems that other solutions have when they deploy Wi-Fi in a standard way outdoor. We had a question here where somebody's asking whether the slides could be available for the solution. And Jeff, I guess I'll defer to you. I don't have an issue with them making them available. If you want to make that available on your website.
Yeah, absolutely. I'll put it on the website sometime this week. If you want it before that, email the email address that's up there, or you can just email me directly, and I'll have somebody, either myself or somebody, send them out to you. And my email is just J, E as in Edward, H, M as in Mary, A as in Apple, N as in Nancy, at converge-tech.com, like in front of you. And then I'll have somebody, or you can just contact your account manager and they'll be able to get it out for you.
Okay. Then there was a question about somebody not able to find the pricing. I think, Jeff, you've got a different URL here than you have for your standard website, right? For the Convergence Broadband is where you'll find the ePMP solution, right?
Correct. Yeah.
Yeah. So I think there was a question, what modulation is assumed? So I think when we're talking about the performance, the numbers I've shown is at the top modulation, which is it's called MCS 15, which is 64 QAMs with 5/6 coding. There's a question about 900 megahertz band availability. So we're not announcing any other bands today, 5 gigahertz today, but we're definitely looking at other bands, and we'll be making some introductions over the coming months. Gino asks, is this a true 90 degree or 90 degree at 6 dB? It's 90 degree at 6 dB roll-off. And we'll be getting the spec sheets for the antennas up on the website here very shortly. There's a question about GUI and SNMP being consistent with the current PMP portfolio. So the GUI is different, very different from the current portfolio. And the MIBs are also unique for this solution. The second part of the question was, can these products be made to sync with standard Cambium PMP radios? And the answer to that is no. The 5 gigahertz PMP radios operate on a 2.5 millisecond frame, and these radios operate on a 5 millisecond frame. So they will sync with each other, but they will not sync with existing Cambium PMP radios. There was a question about the 2.4 gigahertz band. So that is also another band we're looking at. We're not announcing availability at this time, but it's certainly a band that's we're looking at developing the solution in. There was a question here about powering 30 volt DC is difficult in a solar environment. So the power supplies that come with the radios operate at 30 volts, but the range of the range of voltages that the radios will take are significantly go significantly below that. The radios will go, we can power them down to about 10 volts or so. There's higher current draw when that happens. So you just need to make sure you provision, you don't exceed the current draw. But they will operate down to about 10 volts. So that should work well with solar installations. Question about the integrated antennas beam width. It's 24 degrees in the azimuth and 12 degrees in the vertical. Is there a reflector for the SM? So at this time, Cambium doesn't have a reflector available for it. I think you'll probably see some of the players in the industry who typically do develop those kind of solutions. We'll be introducing them for the ePMP, but I don't have any specifics on that today. Question about unsynchronized radios with an external connector, so we can attach external connector. I think the question was, will we have unsynchronized radios with external connector? That's not available today, but that is one of the things we'll be introducing over the next couple of months, which will be a connectorized radio that does not have the GPS device in it. And so that can be used with a panel antenna for either a point-to-point link or a longer range subscriber device. There's a question about the NAT feature in the SM, including PPPoE. It does not include it today. It's on our roadmap for addition down the road, but it's not in the product today. Next question is CNS free? Yes, it is. It's downloadable from our website. Another question, will CNUT deal with these radios? No, CNUT is not compatible with the radios. The CNS is the product that you would use to have that same functionality to upgrade, make software upgrades to your radios. And is it manageable by Wireless Manager? No, Wireless Manager does not support the management of the ePMP. Another question about plans for other frequencies, and as I mentioned, those we're not making any announcements today, but we are definitely looking to expand the portfolio. There was a question about Linux. Given that it's a Linux radio, will it be possible to SSH into the radio? That is not supported today. Another question about 3 gigahertz release. No announcement today. Question is, how does it perform in noisy environments? So it works much better in noisy environments than standard Wi-Fi because it's not a listen before talk type of protocol, but more deterministic GPS synchronized TDD MAC. But if the environment is noisy, you may see some performance degradation as you would in almost all solutions. So we've some of the testing we've done has been in very noisy environments, and it's holding up well. There's a question about the advantages and disadvantages of this product over the PMP 450. So the PMP 450 is our GPS synchronized 2x2 MIMO solution that also operates in the 5 gigahertz band. It's based on a proprietary platform, so that there are some advantages that solution will have relative to the ePMP. One is the efficiency of the MAC layer. While we're able to get some very impressive throughputs out of the ePMP, the PMP 450 is we're able to control the timing of the GPS MAC more precisely, and so it is a bit more efficient than the ePMP. Also, when you deploy it in an AB configuration, you can do that without any guard band between the channels, whereas the ePMP you require a 5 megahertz guard band. So it's really it's another level of efficiency that the PMP 450 achieves. The other thing about the PMP 450 is that it's an outgrowth of the Canopy line of products. So it synchronizes with Canopy, and the feature set and the management solutions are all compatible. They're both good solutions, and depending on the advantages and disadvantages, either one of them one or the other may be a better fit. So what functionality does this solution not offer versus the PMP 450? There's some software features on the PMP 450 which are not yet part of the ePMP. I mentioned one of them earlier. For example, PPPoE client is a supported feature on the 450, not yet on the ePMP. So I think what you'll see is that the PMP 450, because it's an outgrowth of the Canopy line, really has kind of inherited 10 years of feature development from that line of products, and the ePMP will, over time, catch up with them in terms of networking features, but at this point there are some that are not yet available. There's a question about 10 megahertz channels will be an option. Yes, that's definitely on our roadmap. Today it's 20 megahertz and 40 megahertz channels only, but 10 megahertz channel capability is one of our high priority options. There was a question about field testing. We've done a number of betas on the solution, and we're starting to release case studies on those, and will over the next couple of weeks. But we had beta sites in Eastern Europe, North America, couple in North America, and one in the Caribbean region. So as I said, we'll be releasing information about those results over the coming weeks. Still going through the questions here. There's some that are duplicates. There's a question about antennas. So we're the product initial launch will have support 90 and 120 degree antennas. We have immediate availability on the 90-degree antennas, and the 120s will be shipping over the next couple of weeks. We aren't really planning to offer a custom-designed 60-degree antenna with the EP&P unless we get an overwhelming interest in doing that. There are 60-degree antennas that we could recommend with this solution that would work well. So I think that's what we'll be doing, unless again there's a large call for a 60-degree antenna. The antenna spec sheets will have pattern. That was a question there. There's another question about elaborating on the power supply that's required for the radios. So the spec sheets give the the range of power that's required to run the radios. The GPS synchronized radio has got a very wide range of voltages it'll take. I think all the way down below 20 volts and up above 50. And so that's the radio that is 802.3 AF compatible. The integrated radio is not 802.3 AF compatible. The maximum power voltage that it will support is 30 volts, and it will go down to about 10 volts. Question about the power supply polarity. Again, the integrated radio has the same powering scheme as the canopy radios, and the connectorized radio will accept canopy polarity, but also is compatible with 802.3 AF. There's a question about support of BAM or radius. So we don't plan to support BAM, which is a bandwidth. It's a legacy solution from Cambium for managing authentication of subscriber devices. But we will be putting out a software release in December that supports radius. At this time, radius is not supported on the product. There's a few questions here that I not able to answer. I think there's a question about LUID select access from the AP. And that is not supported in this first release, but we will be adding to future software releases the ability to click through from an AP to an SM to manage it, but it's not supported at this time. There was a question about latency on the solution. So we've taken great pains to manage the latency on the solution. You will see, as you increase the number of subscriber devices under the access point, some modest increase in latency, but under all circumstances, We expect it to be under about 30 milliseconds for round trip. So still going through the questions here. So there's a question about the non-line of sight capability of this product. Is this a strict line of sight product? It is not. It's 5 gigahertz. It's unlicensed, so the non-line of sight capability is somewhat limited, as are all products in this category. But we have done some testing of non-line of sight. It performs reasonably well as compared to other solutions in this space. There's a question about whether this product supports inter-tower syncing, and it does. You know, each of the radio devices has a GPS receiver in it, and so they are all synchronized together across the network. If you set up the downlink and uplink ratios the same across the network, then they will all sync. There was a question about automatic transmit power control and whether that's a feature that's on all Canopy radios or just the EPMP. And it is a feature that's on all Canopy radios. Again, the reason we talked about it today was that that's one of the key elements of a GPS synchronized solution that will allow you to do frequency reuse. And the question is, do we have Industry Canada certification yet? And the answer is yes. We have both FCC and IC certification. The question about whether VLAN management is part of the radios, and yes, we do support VLAN. There's another question about the kind of quality of service capabilities we have on the radio. So as I mentioned, it's a 3-level priority scheme where VoIP packets are automatically detected and placed at the highest priority. And then there's 2 other priority levels that the radios can be configured to look at the markings on packets and place them into either of those capabilities. And I think we're at the end of the questions here, Jeff, and probably also just about out of time. Are you there, Jeff?
John, sorry, I had a little problem with my phone.
No problem.
So were you just ending up?
Yes, I went through all of the questions that were posed. There were some duplicates, but I tried to answer all the ones that were unique. And I think we're also just about out of time.
Okay, sounds good. Well, thanks a lot, John. Appreciate your help. And for everybody going to Wispapalooza, we'll be there, and you can talk to John. I think he's going to be there too, but if not, there's going to be plenty of Cambium representatives at the show, so you can see us or Cambium, or just give us a call, and we'd be happy to help out. All right, thanks a lot, John. Everybody have a good day.
Thank you. Bye.